welcome back to our lesson on slopes and tangents. Now, in our previous lesson, we went over what slopes are, we went over what rate of change is, and as well as parallel lines and perpendicular lines. In today's video, we're going to look into how to calculate for the slope and how to go from the y-intercept form into identifying the equation of the tangent. We will also be looking at the equation that's boxed out, which is y minus y1 equals mx minus x1, where we are given a point and then we have to translate it into the y-intercept form. This lesson will be easy, but it requires a lot of initial work. So make sure you guys get a pen and paper ready because practice time. We know we could calculate slope by delta y over delta x. So if we're given, let's say, point A, which is located at 2 and -1, with point B, which is located at 5 and 0. Can you take like a few minutes to figure out what the slope is, and then I'll show you?
Delta y over delta x. So would that be both of the y values over the x values, or?
Yep. So delta y just means change in y. Like delta means change in, okay?
Oh, so you subtract them and then...
Yes.
Okay.
So it would be y2 minus y1.
Over x2. Okay.
Yeah.
Let me just get my notebook.
Okay.
Will that be 1 over 3?
Okay, so let me go about it and I'll show you. I'm not saying it's right or wrong, but I'm just going to do the work, okay? So over here, we would have slope, which is equal to 0 minus -1 over 5 minus 2, which is positive 1 over 3. Okay, question?
No.
No? Let's try another example that's a little bit more challenging. Let's say we had point E, which is located at 1 over 2, -1 over 3, and point F, which is located at -7 and 2 over 5.
Okay.
I'm just going to go over it. Now, when I'm dealing with fractions, instead of having the numerator over the denominator, I like to use the division sign. So I would have m is equal to y2 minus y1 over, in other words, divide, x2 minus x1. And from here, because we're dealing with fractions, we know we need to get the common denominator. So for the y's, the common denominator would be 15.
Yeah.
So multiply the first fraction with 3 with the numerator and the denominator. So that becomes 6 over 15. And then because of the negative and the negative, that would change into positive, and multiply the numerator and denominator by 5. So that's going to be 5 over 15. For the second one, the common denominator is 2. So multiply the numerator and denominator of the first one by 2. That's negative 14 over 2 minus the denominator's already at 2. So we leave it the way that it is. Then we go ahead and we simplify this. So we get 11 over 15 divided by negative 15 over 2. And we know we can't divide fractions, so I'm going to switch the numerator and the denominator. That becomes 11 over 15 times negative 2 over 15. And the next step that I would do is see if I could cancel anything out, but by the looks of it, I can't cancel anything out. So I'm just going to multiply the numerators together and the denominators together. That gives me negative 22 over 225. And that would be my final answer. I know that this is put into the lowest form because in our previous line, we weren't able to simplify anything.
Yeah, that makes sense.
Any questions with it? Okay, so now we know how to get the slope, right? So parallel lines, we would have that the slopes are equal to each other, but the y-intercepts are not equal to each other. Okay? Any questions with that?
No.
So if I had y equals 2x minus 5, what is my slope?
I don't know.
So we need to go back and recall that y equals mx plus b is the y-intercept form of a line. Okay, and over here, this m represents the slope, and this b represents the y-intercept.
This would be 2?
Yeah, so the slope is 2. So if you were told to get the equation of another line that's parallel to the line that's given, what would you say is the equation?
Negative 2?
No. So we could say y equals 2x plus or minus a number where that number cannot equal to negative 5. So you could have said something like y equals 2x plus 1. You could have said something like y equals 2x plus 0, which is just 2x. That k value could be any number other than -5. Why? Because the slope of our equation that was given over here, that is -5, right? And over here for parallel lines, the slopes cannot be the same. Sorry, that y-intercept cannot be the same.
Okay.
So just to go over it again with you, parallel lines are when our slopes are the same, but our y-intercepts are different. So what we would need to do if we were given a question like this, where it said, find another line that's parallel to this line that's given.
Could do like 2x minus 4.
Yep, it could be anything. We just need to make sure that the slope is the same, but the y-intercept is just not 5.
Okay, all right.
So what do you think perpendicular slopes are?
Kind of like perpendicular lines.
Yeah, but how do we know if the slopes are perpendicular?
If they like intersect.
Okay. It's when slope 1 times slope 2 is resultant of -1. Okay? So what does that mean? It means that if my slope 1, let me make a chart. If my slope 1 was resultant of 3, then my slope 2 will be -1/3. If my slope 1 was -5/7, my slope 2 would be 7/5. Okay?
Okay.
So if my slope 1 is -1, what would be my slope 2?
Just 1.
Yeah. If my slope 1 was 1/7, what would be my slope 2?
-7?
Yeah. Question?
No.
So that was perpendicular slopes. Let's look at perpendicular lines. So we know that the slopes have to be perpendicular. And the y-intercept, maybe I'll just write it down. Y-intercept may or may not be the same. If they're the same, it's okay. If they're not the same, it's also okay. All right, it just depends on what you're given and how it tells you to approach it. Sounds good? So over here, let's do an example. Let's say we're given 2x plus 3y minus 1 equals 0. What's your slope?
2x plus 3y.
No. So right now, this is not written in the y-intercept form, right? This over here is written in the standard form. So what we now need to do is convert the standard form into y-intercept form, then figure out what the slope is. So over here, we have to take the 2x and the -1 to the other side because we're trying to isolate for the y. So that gives us 3y equals -2x plus 1. Then we're going to take the 3 to the other side, which means we have to divide every single term by 3. So y is equal to -2 over 3x plus 1 over 3. So now we are given that our slope is what?
-2 over 3x.
Good. Not the x, so slope is just a number, no variable attached to it. So it's just going to be -2 over 3.
Okay, all right.
So what would be the perpendicular slope?
It would be +3 over 2.
Good. And now that we have this, we could figure out the equation of another line that's perpendicular to the line that was given. Can you tell me an equation?
The equation of the parallel slope, or
Perpendicular.
would it just be y equals 3 over 2x plus 1 over 3?
Yeah, we could have the same slope, okay? So this is fine, but in general, if you wanted to state something, you could have just said k, and then you state that k belongs to all real numbers.
Okay.
Whereas with the parallel line, if you look over here, there is a restriction for k, just because the slopes cannot be the y-intercepts cannot be the same.
Okay, all right, that makes sense.
Okay. Any question with this?
Nope.
Any questions with converting standard form to y-intercept form?
No.
Okay. Pass it. Okay, I'll write it down. Find an equation that passes through, let's say 2, 1 and -3, 1, or -3 and 4.
So I would first find the slope.
Good.
So that would be 1 over 2 minus -3. 3 over, the slope is 3 over 5.
Careful with your signs. You want to be careful with your signs because it's 4 minus 1 over -3 minus 2, which is 3 over -5. So this would be your slope over here, not 3 over 5, 3 over -5. So your slope is a negative, not a positive.
2 minus -3. Wouldn't it be 2 minus -3? Not.
Well, we use this as our
2 minus 2. Yeah. Okay.
We use this as our y2, so we have to use this as our x2.
Yeah.
This is our y1, so this has to be x1. So you need to make sure that your whichever point you choose as x1 and y1, they are corresponding with each other. You can't do y x2 minus y1 over x1 minus x2.
Yeah.
Okay, so you got your slope. What's your next step?
So I have my slope. Would the equation be 3 over negative 5x plus k plus or minus k, or?
No, because what I need to do is either use point 1, I'm going to call this A, or use point 2, I'm going to call this B, in order to figure out what my equation is. So do you want to use point 1 or point 2?
Point 1.
Okay, so then I have y minus y1 equals mx minus x1. This over here is just a formula, okay?
Okay.
Does that make sense?
Yeah.
So then it's going to be y minus 1 equals negative 5, or sorry, it's negative 3 over 5 times x minus 2. I'll use distributive property over here. So I have y minus 1 equals negative 3 over 5 plus 6 over 5. Then I'm going to bring the negative 1 to the other side. Y equals negative 3 over 5x plus 6 over 5 plus 1. And I need to get that common denominator. So y equals negative 3 over 5x plus 6 over 5 plus 5 over 5, which then becomes negative 3 over 5x plus 11 over 5. And that over there will be the equation. So this is your final answer.
Okay, let me just write this down.
Okay. And let's say x-intercept at 3. How would you go about doing this question?
I'm not sure. I have no clue.
So what you should do first is, this right now doesn't look like a point, but change it so it does look like a point. So what point is this at? What is the coordinate point of this?
Something and negative 5.
What a negative 5?
I'm not sure. Oh, would it be 3 and negative 5?
No, 0 and negative 5. So y-intercept, we know that x is always located at 0.
Oh yeah, okay.
So what would this particular point be located?
3 and 0.
Good. So now that we have the 2 points, what do we need to do?
Find the slope and then find the equation after the slope.
Okay. So what's our slope?
It would be 0 minus negative 5, which is 5. And then 3 minus 0, so 5 over 3.
Yep. Let me write it down so you could see it more clear.
And then we'd apply the y minus y1 equals m times x minus x1 formula?
We actually do not need to do that because we're already given what the y-intercept is, right?
Uh-huh.
So we
Oh,
don't need to do that
so just
extra step.
find the slope, and then -5 equals 5 over 3x plus 3.
No, it's going to be y. Okay, so we know it's y equals mx plus b. We just figured out what our slope is, right?
Uh-huh.
So next, we would figure out what our y-intercept is, which is given to us right here.
Uh-huh.
So we just plug those two values in. So it's going to be y equals 5 over 3x minus 5.
Oh, okay. What about the 3?
We're just trying to figure out the equation of the tangent.
Okay.
What's your question in terms of what about the 3?
Like, do we not use it after
Why do we need to use it?
finding the slope?
But why do we need to use it? That's what I want to know.
To figure out the slope.
But we already figured out the slope over here.
So after that, we just wouldn't use it at all.
Well, we don't need to because the y-intercept is given to us.
Okay, yeah.
That was just dealing with slope and, okay, I'm gonna refresh it one more time. This is just for calculating slope. We know that slope is the change in the y value over the change in the x value. That's our fundamental understanding of slope, right?
Yeah.
Then we go into trying to understand what is a parallel line versus a perpendicular line. And to help us figure that out, we need to understand the y-intercept form of a line, okay? We know that the y-intercept form of a line is y equals mx plus b, where the m represents the slope and the b represents the y-intercept. So when we are talking about parallel slopes, we know that the slopes will be the same. And when we're talking about parallel lines, our slopes are the same, but our y-intercepts are different. Moving forward to perpendicular lines, these are lines that meet at a 90-degree angle. And in order for us to figure out what the slope will be, when we multiply the slopes together, it will result to -1. And in other words, the slopes are negative reciprocal of each other. And when we're looking at perpendicular lines, our slopes do need to be negative reciprocals, and our y-intercept does not have any restriction like our parallel lines did. And then moving forward with some thinking questions. If we are given 2 points, the first thing that we would need to do is make sure we figure out what the slope is. And then once we have figured out what our slope is, we plug it into the equation. And we also use one of the points in order to figure out what the equation would be. We could have used either one of the points, it's up to us, but when we are picking the points, we want to choose the one that we think will make our life easier. So I would have avoided B just because there's a negative. Negatives make our lives a little bit more complicated, so that's why we would want to avoid B. With that said, we could have picked B as well. The main thing that we want to take away from this particular question is knowing that the y-intercept means that our x value is 0, and our x-intercept means that the y value is 0. So when approaching a question like this, where it gives us either the x or y-intercept, what we want to do first is convert that into a coordinate point. And then if the slope is not given, figure out what the slope is. And after, if our y-intercept is not given, then we would figure out what our y-intercept is based on the formula right here.
Okay.
But if the y-intercept is given, there's no point of doing additional extra steps.
Yeah, that makes sense.
Good?